Okay, so this is rational expressions. The first one, all we're supposed to do is just simplify it. So if you look, the first thing I want to do is I want to factor the numerator and I want to factor the denominator. We've already spent time factoring, so hopefully you'll be able to factor these very quickly. The top factors as m minus 2 times m minus 2. You could write that m minus 2 squared, but I think it may be easier if you have 2 of them in the numerator. Then I'm going to factor m squared plus m minus 6. Remember, in all your factoring rules, that factors as m plus 3 and m minus 2. Now, what I'm going to look at is I'm going to see if there's any factors that are in common on the top and on the bottom. If so, they're going to what we call cancel out, but typically what we say is that they just zero out. So, or they make 1. So the m minus 2's and the m minus 2's are the same, so I'm going to cross them out. Notice I don't have any more m minus 2 in the denominators, and I don't have any more m plus 3's in the numerator. So my answer is m minus 2 and m plus 3. Notice if it asks about the domain, remember the denominator cannot be 0, so it's everything except x equals negative 3, because negative 3 would make the denominator 0. So make sure you remember your domain and your range. If you look at the next problem, this is a division problem. The first thing that you're going to want to do is you're going to want to just make sure that you change this to a multiplication symbol. So I'm not going to do any factoring yet. Change this to a multiplication symbol, and then my next fraction is going to flip. Remember, when you divide, you multiply by the reciprocal. So that a squared minus a minus 20 is going to go on top, and that a squared minus 9 is going to go on top, on bottom. At this point, it's easy to just factor each of the numerators and the denominators. So here, 4a plus 12, remember your GCF, so I can take out a 4, and I will be left with a plus 3. Same thing in the denominator. In the first fraction, I can take out a 2, and I'll be left with a minus 5. And then here, a squared minus a minus 20 is going to factor as a minus 5, a plus 4, and then the denominator is going to factor as a difference of 2 squares, a minus 3, a plus 3. So what I'm going to do is I'm going to look, and I have an a plus 3 here in the numerator. Look down in this denominator all the way across, and I see that I have another a plus 3 in the denominator. So that's going to make 1 in the division. And then I have an a minus 5 in the numerator, and then down here I have an a minus 5. So pretty much all of my binomials are pretty much simplified. Remember, 4 divided by 2 is 2. And then I'm just going to write whatever I have left. So 2 times a plus 4 divided by a minus 3. If you want to give the answer as 2a plus 8 over a minus 3, that's perfectly fine. Typically, we leave it with the factored form, and the domain is everything but positive 3, because remember, your denominator cannot be 0. Then I've got one other problem to show with rational expressions, and that is an addition and also a subtraction problem. You do them the same exact way, but you'll just do a different operation. So if you'll give me a few minutes to write this one down. So we've got x plus y over 2x minus y, 2x over y minus 2x. Now, the common mistake with this one is that everybody thinks that these two things are the same exact thing, but they're not. The y is negative here, the y is positive here, the 2x is positive, the 2x is negative here. So they're two totally different binomials. So in order to get a common denominator, just like you used to do in elementary school, you're going to do the same thing with these binomials. In order to get them to go away, I need to make sure that I have a 2x minus y and a y minus 2. So I'm going to do things a little bit differently than the way your book does. Hopefully, this will make a little bit more sense to you. So I'm going to take this fraction and I'm going to multiply it by 2x minus y and y minus 2x. I'm going to multiply by everything that I need in that denominator. And same thing here, 2x minus y and y minus 2x. Now, I'm going to look at each fraction individually. So if I look at this fraction, I'm going to compare this stuff in purple with the denominator. Notice the 2x minus y's are the same exact thing. So they are going to cancel out. And I'm going to be left with the x plus y and the y minus 2x. And then that fraction, for the most part right now, is complete. The next fraction, I've got a y minus 2x in the denominator, and then up top I have what's in purple, 2x minus y and y minus 2x. Since I'm multiplying, the y minus 2x are going to go away, and what I'm going to be left with is that minus sign. Don't forget that minus sign, a 2x and a 2x minus y. And then notice my fractions have gone away. That trick kind of works to help simplify the problem a little bit. Now, I'm going to work in these green binomials. So remember, you're going to have to full this out. Your first term times your first term. So x times y, which is xy. Your outer terms, which are x and negative 2x, which is negative 2x squared. Your inside terms, which is y times y, which is y squared. And then finally your last terms, which is y times negative 2x, which is negative 2xy. So the green is fulled out. So now I'm going to go to the blue. I'm not going to do full here. I'm going to do the distributive property because this is a monomial times a binomial. Make sure you multiply by negative 2x. Negative 2x times positive 2x is negative 4x squared. And then negative 2x times negative y is a positive 2xy. Still got a little bit of work left to do in this problem because I've got to combine like terms. I'm going to write it in standard form because that's typically how we like to do it, and we like to write it in alphabetical order. So negative 4x squared and negative 2x squared makes negative 6x squared. And then my xy's, I've got a 1xy, a negative 2xy, and a 2xy. Notice that these 2xy's are going to zero out, and I'm going to be left with xy. And then finally, the only thing left is a plus y squared, and then that's about all that I can do with that problem. And so that wasn't a subtraction problem. You'll do the same thing with an addition, except if it was a plus here, I would just multiply by 2x and then add my terms.